Gigo.
Hello everyone, I'm Teacher Sloth. In an era where science and technology are so advanced, Gigo is also constantly improving our products. Today we're going to introduce the new product, Robotics Workshop compatible with microbit. Now, let's unbox it and see what parts are in this package and what functions it has. Here we can see the basic parts of C-block system, such as 5x10 frames, 5x5 frames, and rods. Then we also have some parts for connection, like static axle connector, or gears. This bag contains decorative accessories such as 60 Tesla gears, belts, and wheels. These are ultrasonic sensor, 50x planetary motors, and 180 servo motor. Finally, the most important part in this kit, the microbit smart controller. I'll show you what the new smart controller can do later. Next, let us get to know the core part of Hash 1409, the microbit smart controller. As you can see, compared to the controller of Hash 1269, the overall size is smaller. Here we keep a space for micro-bit touch sensor. This way you can perform different programs or operations by touch sensor. For button A and button B, now it will have a feedback feel when pressed, to let you know clearly that you're pressing the button. In the lower right corner is its power switch. After pressing, if you see the microbit lighting, it means it has been successfully activated. Here we'll display LED matrix. You can use the button A or button B to present different graphics. Next is the I/O port. Although there are only 4 sets of I/O port, it can be connected to all Gigo motors or sensors, and 8 sets of DuPont connectors. This is a new connector for color sensor. You can learn more details in the Hash 1409A. Each motor connector will have its number written next to it. In this way, you can directly look at this and write the program without manual. Let's take a look at the side and the back. It is a DC 5 volts charging port. You can use Type-C cable to charge the battery. The holes at the back are designed deeper for the static axle connector. It needs to be deeper so that static axle connector can be completely connected with it. The static axle connector can be disassembled easily. The most special design of smart controller is the new design of battery cover. To open the battery cover, use the tool for battery compartment. Insert the axle into the bottom hole. Push the tool to unlock and slide down the battery cover. After opening it, you will see two 18,653.7 volts lithium-ion batteries inside. This smart controller can step down a total of 7.4 volts current to 5 volts. In this way, it can support up to 4 motors operating at the same time. Okay, slide and push the battery cover back. Its overall operation is quite simple and does not require other tools. Now, let's check the differences in operation and functions between Hash 1409 and Hash 1269. In addition to the building blocks, this package also includes this sorting tray which allow you to easily organize all the parts. It also includes this full color manual, which provides detailed instructions on how to use smart controllers and how to write programs and how to create these models. Now, let's assemble the model quickly and write a program to test it. Okay, we've completed the smart fan now. we'll start doing some programming. Then send the program to the device and see it in action. Let's get started. Make sure there is an option on the left called Robotics Workshop. This option contains program blocks for motors and ultrasonic sensor. If you don't have this option, don't worry. Click Extensions. A dialog box will pop up when clicked. Key in the URL link and click the Enter button. You can see Robotics Workshop below, so click it. A new option, Robotics Workshop, appears on the left side. I believe that everyone is already very familiar with some functions of microbit web page, including logic, input, and even variables. So we won't go into details here, and directly to program the smart fan. Okay, these were all the programs for Smart Fan. Let me explain the logic of this program. First, when we start it, the speed value will be set to 0 to avoid accident operation. When we press button A, its speed value will be increased by 15. If we press button B, the speed value will be set to 0. What does it do repeatedly? First, we make the screen always show the number of speed. When we press the micro-bit logo, its speed value will continue to increase by 5. If the number of speed value becomes bigger than 30, we make it 30. Our motor can be set to a speed of up to 100. But in fact, the speeds of 130 are almost the same in our human eyes, so we don't need to set the motor speed too high. And it can also prevent you from accidentally hurting your hand when you touch it. The motor spins according to the number of variable speed. As long as you choose speed block, the direction of the motor is 1, which means rotate clockwise. Okay, these were all the programs for this project. Let's send the program to the device and see it in action. Let's start the test. First, turn on the power. The red light here means it is turned on. It displays 0, which is the speed we set at the beginning. When we press button A, its speed value will be increased by 15. This makes a motor start spinning. If we press button B, the speed value will be set to 0. This makes the motor stop spinning. Next is the microbit touch sensor. When we keep pressing the microbit logo, you can see that the speed value keeps increasing. After reaching a certain value, about 15, the motor will start spinning and continue to increase the speed value. Then we set the upper limit to 30 so that accidents will be prevented. The next sensor we are going to add is the ultrasonic sensor. Its characteristic is that its two eyes can emit ultrasonic waves. After the ultrasonic wave hits the object and rebounds, the sensor can detect the distance between it and the object. Then you can achieve functions such as obstacle avoidance or sensing. Let's try to add new function for Smart Fan now. Okay, we're rewriting the program for our ultrasonic sensor. The biggest difference between old program is it adds a new variable called distance. The variable distance will be based on the value sensed by the ultrasonic sensor to perform different actions and reactions. The farther the ultrasonic sensor is from the object, the greater the value it will get. The closer the distance is, the smaller the value will be. What we want to make is a smart fan that can save energy and only activate when someone in front. If the sensor says something is closer than 10 centimeters, we set speed to 15. This makes the fan turn on. If the distance is more than 10 centimeters, we set speed to 0. This stops the fan to save energy. The motor will still rotate clockwise according to the value of the variable speed. Now let's send the program to the device again and see it in action. Let's start the test. First, turn on the power. You can see that when the power is turned on, it doesn't do anything. When will it take action? Until my hand is close to the ultrasonic sensor, the fan will start spinning. If my hand slowly move away from it, it will stop immediately because it detects nothing. Well done! This was how to program the smart fan with ultrasonic sensor. This was the introduction video of Robotics Workshop compatible with microbit. If you want to learn more, you can also refer to our #1409A, which including infrared sensors and color sensors, or #1409B, which including AI lenses, can realize the functions of AI technology. I am Teacher Sloth. Thanks for watching.